many people are students of history? Is there any hand at all? Okay. All right. So there's a few of you out there, and I like to look at things from where have they come from, where are they going, and that's going to be sort of what I'm going to do today with Chord. I'm going to give you a little bit of a perspective of how it got started, where it's been, what things have happened, and then sort of talk a little bit about where it might be going looking forward. So let's have some fun with this, why don't we? So starting off in historical perspective, and it seems kind of strange when it's only been 2 years or so to talk about ancient history of Chord. It didn't used to be called Chord, right? If you go back 2 years ago, there was Onos, and Onos came first, right? And then there was this thing, well, we've got this operating system, what do you do with it, right? It's like the classical operating system question. And you need some apps for an operating system to be useful. And so the first things that happened is we created some use cases. How would you make use of Onos? And the top three there was, well, gosh, you could use it for residential access, you could use it for mobile access, you could use it for enterprise. It's sort of like the big segments that happen in most telco networks, right? And then it didn't take very long to understand that, well, wait a minute, you can add some applications on top of Onos, but you still need more. Right? If you want this to be something that people can make use of, solve real problems in real networks, you're going to have to add some surround to it. And suddenly we got these kind of things that are sort of platforms or add-ons that came along. The whole notion that you had to build on OpenStack and that you wanted NFV infrastructure for Chord to run on came out, right? The whole thing that it was called Chord came out in this time frame. XOS as a way to put together things, that there was something beyond just OpenStack needed to put together telco solutions. And last but not least, the A-Chord, the analytics, the fact that you want to measure what you're providing. So all of these things started off, and it sort of gave Chord its bootstrap from the very beginning. So at the beginning also, there was an early kind of linkage to Open Compute project. When we started putting together Chord as a platform, we started with some OCP servers. In fact, they were Quanta servers. Thank you very much. And we had some switches. They were from the other guys, right, up the street. But these were all OCP open spec hardware. They were available. You could run any kind of operating system or any kind of networking system in these boxes that you wanted to. And indeed, it was one of we found that kind of hardware was most amenable to being controlled with SDN, right, with OpenFlow, which was kind of one of those initial things that Onos really tried to put out into the market. And then there's this sort of other thing that was happening at the time, and at AT&T, we were starting to look at the early virtual network functions that came out for SDN and NFV, and we found that they were just replicas of the vertically integrated boxes. And so if you've heard the terms like disaggregation and refactoring and these types of things, we realized that in order to make most reuse of the software that was being developed for SDN and NFV, you need to have simpler, more reusable functions. And so this disaggregation came about, and it started with some of the new specs that we developed at OCP. And you've heard Guru talk a little bit about the OLTs, and you'll see them in the next chart as well. So in order to understand how all of this stuff would fit together, it's also been over a year now. There was an initial AT&T field trial where we took all of this open hardware, the initial open spec OLT for GPON, and put it out into the field to see how it would work. And I'm happy to say it's still out in the field. It's still working. We've done a number of upgrades over the course of the year. It's now getting upgraded to support XGS-PON, which is 10 by 10 gig. So it's pretty cool stuff. And it also brought about the birth of Volta. That, you know, we had these white box access devices, and there wasn't just sort of a vendor to go and ask for a driver for that merchant silicon like there had been for some of the switches before. So how do you build these kinds of software stacks? And what we found is that Volta was a good answer to the problem that we were facing at the time. Okay, So, in a couple of pictures here, we spoke about this. The GPON OLT was sort of the first OCP white box access device. And you know what? AT&T's interest has really shifted pretty strongly to XGS-PON, but you know what? If Telefonica were here, I think that you would want to talk to them about the GPON OLT. It's not my place to sort of take their thunder, but they've come a long way with that platform, and I'm sort of really proud of where they stand. So, Alfonso, here's a shout out for you. AT&T is focused right now on XGS-PON. I talked about our field trial. It's something that we're transitioning to this week in the field, so we're really eager and nervous about rolling that out. And we're working diligently on adding other access technologies like GFAST and hopefully in the future fixed wireless to the panoply of things. So if we go back about a year, you've probably seen this chart. Gosh, how many times has Guru presented it? Okay. So the idea here behind Cord was that we wanted to be extremely agile. We knew that new kinds of services were coming out. There's 5G, there's the Internet of Things, there's all kinds of new innovative stuff happening, not at the packet shuffling level, but at the application layer. And so we knew from a network architecture perspective, what we really needed was a way that we could move quickly. And so moving quickly doesn't mean you go to some standards body and you create use cases and you work for 10 years to come up with standards that are, hard-baked. It means having something that works a lot more like the web-scale data centers do, where you can move agilely, you can try something and you can move on. If it works or it doesn't work, you either build upon it or try something new, and you're very nimble in that type of way. And so that's really kind of the fundamental behind Cord and why you would want to do something, why you'd want to change your central office to work like a data center. And then I've presented this before. There's a whole long list, and I don't think I'm going to walk through them individually, but there's a whole kinds of many different things that carriers desire out of a next generation network or out of an infrastructure that they deploy. And the argument here is that Cord has actually sort of broken open this sort of narrow SDN view of the world. There was originally an ONOS. ONOS solved sort of a control for SDN problem, but the problem for the business problem for the carrier was much broader. And by moving from just focusing on ONOS to focusing on Cord, we've gone kind of like working on the Linux kernel to developing a distro, right? A Linux kernel all by itself is not very useful if any of you have played around with it. But if you get a whole distro from a Red Hat or a Canonical, that's actually something very useful. And I think that the same thing has happened here, that the ONF has moved interestingly towards something that's more like a distro and more easy to ingest, to understand, to put up into a lab environment so that you can kind of work with it and move forward from there. All right. Okay, so where is AT&T right now? That's okay, we've gone through the history. Let's kind of talk about where we are today. AT&T still has interest in a lot of the original use cases that you've heard about Cord. In the meantime, we've done some other interesting work in another area. So the first thing here, and that's probably, it's definitely on my mind almost all the time, but it might be on some of your minds too, and that is that with this ONAP thing that AT&T has open sourced, how does that relate to Cord? And I could tell you I'm very eager to figure that out. It's obviously not done yet, but it's, I think, something that I hope many other service providers would be very interested in. We certainly are very interested in that, and that's, I think, a really interesting place moving forward. I talked earlier about our field trial. That was around our Cord. That was a wireline for PON, for consumer broadband access. And we're definitely interested in our Cord. We're in a fairly advanced stage with that field trial. M-Cord is another item that we're really interested in. We think a lot like, I believe, some of the other carriers that Guru mentioned, that the Cord as a platform at the edge of the network isn't just dedicated to one type of an access or another type of an access, but rather it's multi-access, and that you'd want to support, if you're a carrier that has wireless and wireline and whatnot, you'd want all of that to be supported in one cord without different instances or different stacks, or it should be a fairly integrated kind of an approach. Right and light infrastructure. So this is a notion that we kind of put out there to say if the cord platform is something that is intended for the edge of the network, then the edge of the network can often get really edgy, right? It's something that there may be an office with, let's say, a few thousand customers that attach to it. And if you count a few thousand customers, that probably fits on one of these OLT, 1RU blades. So the interesting scaling problem for cord isn't necessarily to become huge like a web scale data center. It may actually be to get tiny, to find ways for to be deployed at the edge where you need to put the access, but where you don't have such a large demand or a large set of customers that you can afford to put rows and rows of equipment out there. So that's very much on our mind. And then last but not least, we've been really active in Volta. Volta is, here we go, virtual OLT abstraction, hardware abstraction. And so it started with our first open spec GPON white box. What we found is that it was the weakest link in the chain, in the whole software stack, was actually getting that OpenFlow driver to command or control the merchant silicon for access. There'd been a fair amount of work that came before in data centers for top-of-rack switches, but essentially nothing for access silicon. And so we definitely went through the bleeding edge, if you know what I mean, with getting that initial OLT up and running and into the field. What we realized is that this would come up again and again. We didn't intend just to have one OLT with just GPON from one vendor. What we intended is to have a lot of vendors with a lot of different access technologies that could be plugged into Cord and ONOS with very little work and change necessary when you change them. So the upshot was, instead of trying to recreate this driver over and over again every time a new network technology or a new vendor of the same technology came along, we thought it better to have sort of a starter kit, where if you think about, there's a Volta core that has all of the basic state that you need in the access silicon to manage access. And we have it's almost like a mirror image of what happened in ONOS, that you've got plugins that connect you to various types of merchant silicon. And here we got merchant silicon, but also especially in the XGS-PON realm, there's a lot of FPGA code. So a lot of times there's very limited access to merchant silicon. People solve the problems in FPGAs, so they wind up having pretty much a proprietary interface, and that might be for each vendor. The good news is that hardware abstraction can manage all of these in a similar way, and then you can choose what you plug in at the top. Obviously, in this venue, we plug it into ONOS, into Cord, right? But with OpenFlow and NetConf interfaces, you can do essentially whatever you like in that space. And we think this will accelerate the adoption of these disaggregated access devices. All right, so lastly, the idea is where should we go with Cord from here? And so we've had some experience with Cord in the field. We've had a lot of experience with Cord in the lab. We get I think that the industry has done some maturing on how you make use of Cord and where is its niche, where is the sweet spot for its deployment. And so here's kind of a list of things that I think should be on your minds as we go forward these next 3 days. The first one is around adoption. And so a lot of times Cord is one of those things where you could bring it easily into a lab. You can bring up Cord in a box, right? But typically what you can't do easily is if you have a whole set of legacy OSS, BSS, if you have a number of other things you've deployed that aren't cord, but you want it to work with, you may find that you need to take cord and sort of disaggregate the cord itself, so that I'm going to borrow the Volta or I'm going to borrow the apps on top of Onos, and I need to mate that with a conglomeration, some new white box elements, some older classical network elements. And I think that cord needs to kind of get this flexibility where we get beyond just sort of the one cord distro into where we understand how to take bits and pieces of cord to solve real problems in real carrier networks. Secondly, I think that more focus on the community. That, well, let's face it, a lot of the work that was done early on in cord was done at the ONF. And so the ONF people, yeah, thank you, by the way. So it was a completely new sort of model, and it really, I think, was earth-shattering. A lot of carriers didn't have a lot of software developers. So having a community where you didn't have to bring in software developers in order to participate, but actually there was a core group of software developers that were kind of part of the community, really was enabling. And I think that focusing more on this community, not relying on just the few software developers that ONF has, but getting more and more participation from a broader set of inputs is kind of key to launching into that next stage for cord. As a community, cord, I think, and ONF in general, I think needs to have some really good, strong relationships with adjacent open source communities. First step's already taken, right? Entering into the Linux Foundation and becoming part of that community and that kind of, what I would call general operating principles and rules. That's a great first step. But there are a number of, the OCP is like a no-brainer, right? It already is almost an unwritten liaison between the ONF and OCP. And I think there are other environments that I think we'd like to see that kind of connectivity or that kind of relationship come together with. And then last but not least, and Guru ended very similarly, and that is that cord right now, I think, is this wonderful pre-commercial platform. So it shows tremendous potential. It's good enough, I think, for a field trial with some limitations, but there is this entrepreneurial opportunity out there for you potential suppliers that cord still needs to take that last step to commercialization. And that's a big opportunity for folks who would wind up selling and supporting and providing cord as a business opportunity. So there you have it. Thank you very much for listening to me today. I really am appreciative for the chance to come up here and give my perspectives about where cord came from and where I think we should go with it. So thank you very much.